And then I'm a millennial, so I wait till to make sure that it's recording before I start talking. What? Okay. So let's review what we talked about the last class. So we introduced Rolle's theorem, which is an existence theorem, kind of like intermediate value theorem is an existence theorem. And the conditions for Rolle's theorem to apply are that the function has to be continuous on the closed interval and differentiable on the open interval. And the reason we have the differentiability requirement is because Rolle's theorem, like mean value theorem, which it's kind of under the umbrella of, is proving the existence of a rate of change. So like proving the existence of a derivative value. So function has to be continuous on the closed interval, differentiable on the open interval, and if f of a is equal to f of b, so if the function values at the endpoints are equal to each other, then there's at least one number c, so one x value on the open interval from a to b such that f prime of c is equal to 0. So it's saying if the slope of the secant line for that interval is 0, like there's a horizontal secant line, that means somewhere else on the interval there's going to be a horizontal tangent line. We're okay with that? Okay. So let's get into now the examples that I've chosen for these notes. They're all like kind of more like our textbook, and the wording of our textbook problems is kind of open-ended, whereas like College Board is very direct in their questions and clear in what they're what the question is asking. So I want to break this down a little bit. So this example says find the two x-intercepts of f of x, so that quadratic function, and then show that f prime of x is equal to 0 at some point between the two x-intercepts. So I'm going to break this into 3 steps. So the first step is we are going to find the x-intercepts. Okay, and then we are going to justify the existence of a horizontal tangent line on the open interval. So like justify looking for that horizontal tangent line. And then the third question or the third part is we're going to find all the values. Okay, so first of all, if we wanted to find the x-intercepts of this quadratic function, what should we do? Factor that puppy. So f of x, right, can factor to, what is that, x minus 2 minus 1. And if we set that equal to 0 by the zero product property, right, we could say x equals to 2 or x equals to positive 1. Like those would be the zeros of the function, which would then correspond to the two x-intercepts, 2, 0 and 1, 0. Is everyone with me to here? Yes. So the interval that we are going to be considering for then identifying a potential point where the slope of the tangent line would be 0, so the value of the tangent line would be 0. The interval that we will be talking about will be what? 1 to 2, right? Because the function values are going to be equal at those endpoints. So we're moving on to our justifying existence question. And we can say, so f is, well, actually, let's pause for a second and talk about this. What type of function is f of x? It's a quadratic, but like bigger picture, it's a polynomial. And we know that when we hear the word polynomial, we immediately think, what about their graphs? Smooth and continuous, right? So continuous, but then the smooth indicates what? That it's differentiable. So we can say that f is continuous on
Doesn't continuous imply that it is smooth?
No. Think absolute value of x.
Oh, you're right.
At x8. No, so no sharp corners. So polynomials, right? Like it is understood for us that polynomials are smooth, continuous curves, right? So they are continuous, but they're also differentiable everywhere. So f is continuous on the closed interval from 1 to 2 and differentiable. Wow. On the interval from 1 to 2. And somebody asked me this morning, they're like, do you have to say, like, because it's a polynomial function? To be honest, if this is coming up in a free response situation, you would be given other information that you'd be interpreting for the function being continuous on the closed interval and differentiable on the open interval. If you want to include, like, because f is a polynomial function, like, you can. But I think it's okay for us to assume, like, because we know this is a polynomial function, we can look at that and be like, it's continuous and it's differentiable. Okay, so since f of 1 is equal to f of 2, which is 0, by Rolle's theorem, there exists, or there must exist, a value on the open interval from 1 to 2 such that f prime of x would be equal to 0. Oh, it's like lagging right now. I wonder if that's because I'm recording. Like it finished writing and I was still I was done writing. Yeah.
Can you explain like how you know like if it's open or closed?
Going back to the conditions for Rolle's theorem.
Oh, well.
Okay, so the function has to be continuous on the closed interval because you're considering the function values at the endpoints. Okay, and the fact that they're equal to each other. And then differentiable on the open interval because you're trying to prove the existence of value of the derivative function on the interval, right? So everywhere from A to B on the open interval, not at the endpoints, the function has to be differentiable because we're trying to prove the existence that f prime is equal to 0 somewhere on that interval. Okay. So now we've proved its existence referencing Rolle's theorem, so we can go ahead and find the values of x where f prime would be 0. Value or values. Okay, so we need f prime. Little power rule. F prime will be, what is that? 2x minus 3. So then if we think about setting f prime equal to 0, we get that x is equal to 3 halves. Okay, so it's at x equal to 3 halves, or f prime of 3 halves, we could say would be equal to 0. This is going to be annoying in the video because it's kind of lagged. Like my talking doesn't line up with the writing. Sorry.
Like a second max.
Huh?
There's probably like a second.
Yeah, we'll see. That's okay. Okay. So let's let's do one more together. I'm going to have you guys do the mean value ones in groups, just so you get a little bit more experience, because it's a very similar process when we talk mean value theorem as it is with Rolle's, and it kind of rolls into mean value theorem.
Wait, but isn't this the last one though? There's no other Rolle's theorem.
I know, but Rolle's theorem, like you don't technically have to remember Rolle's theorem by name, because...
No, because you wanted us to do stuff in groups.
No, I know. We're going to have mean value theorem ones, though.
Oh, okay.
Yeah, don't worry. I got it figured out. Okay, so kind of similar question, right? So let this polynomial function, f of x, be equal to x to the fourth minus 2x squared, and we're finding all the values of c in the interval from -2 to 2 such that f prime c is equal to 0. So we're going to go a little bit further than what like this question is asking. And we are first going to justify the existence of c. with mean value theorem, with Rolle's theorem, not mean value theorem. And then we are going to find C. Okay, so again, this is a polynomial function. F is a polynomial function, so we could say F is continuous on the closed interval from -2 to 2 and differentiable on the open interval from -2 to 2. And since, well, actually, we need to check the function values at the endpoints, huh? We need to think about, well, what would f of -2 be and what would f of +2 be? So -2 to the 4th would be 16. And then -8 will be 8. And then since that's to the 4th and to the 2nd power, it's going to be the same thing. Okay, so since f of -2 equals to f of 2, which is equal to 8, by Rolle's theorem, there must exist a value C on the open interval from -2 to 2 such that f prime of C is equal to 0. Use the language that's in the problem. Okay, so we know that there is at least one C because the conditions for Rolle's theorem applies. And now we can find the location or locations where those values would occur. So we can find f prime. Okay, and then we are setting f prime equal to 0. And we can solve that by factoring. So factor out the 4x. Factor the difference of squares. Okay, so we get x equals to 0, 1, or -1. And just to make sure we're appropriately answering the question, I can say the values of C such that f prime of C is equal to 0 on the interval from -2 to 2 are C equals to 0, C equals to 1, and C equals to -1. And make sure you're checking that, oh yeah, all three of those values would lie on the interval from -2 to 2. If we got like C equals to 7, we're like, oh, nope, not on the interval. Okay.
Are we getting grouped by GPA now?
No, I tried. Do you guys want to hear what I tried this morning? I had everyone compare the length of their right arm and try and line up from longest arm to shortest. And I know they didn't take it seriously because Aiden V put himself as like the shortest arm, and then I had like Caitlin Kramer up here. I was like, no, I don't think.
No, I don't think
It was tricky. It was tricky.
That was annoying.
It was tricky. That sounds annoying.
Yeah, it's just annoying. But I feel like
Um,
who can say who
Who
has a better
have we done hair length? I've done hair length for other
who has
classes.
better 6'7"?
Like, you know, we have one
Who can
A,
scream 6'7" loud,
one
bro?
B, one C.
Yeah, like curly.
No, that's how you classify your hair. Like, I know I have 2C hair.
What's mine?
One A.
One B or one A.
Well, like, this is pretty straight.
Mine's very straight.
Yours is like.
All right, you guys.
One B, one C.
So again, Rolle's theorem is this very specific case of proving the existence of the derivative being equal to 0. Okay. Now, Rolle's theorem can be used to prove mean value theorem. Mean value theorem, the conditions are very similar. And mean value theorem is in order to prove the existence of just a rate of change, not necessarily a rate of change being equal to 0. So the value of the derivative being equal to something, just not necessarily 0. Okay? So MVT says the secant line between 2 points, a comma f of a and b comma f of b, on a graph is parallel to at least one tangent line on the open interval from a to b. So because two lines are parallel if they have the same slope, what the MVT claims is that there exists a point C between a and b such that the slope of the tangent line is equal to the slope of the secant line, which is basically what Rolle's theorem says, but Rolle's theorem is just focusing on whenever the secant line is horizontal. So really, we could use mean value theorem in order to prove the existence of f prime being equal to 0. Right? Are you loving this so much?
This is kind of cool.
What are you laughing at?
Would
Would you like to share? You're giggling over
Is that
here.
a D?
A what?
Is that a D?
The no?
Yeah.
Could be like this.
Are you thinking about having to measure your right arm against reaching?
Oh my god, are we
Like,
serious
oh.
now?
Oh.
Wait, Rich, you only measured the left?
Okay.
This is
So
fine.
let's go through the formal conditions for mean value theorem to apply. So again, f has to be continuous on the closed interval, differentiable on the open interval. And a lot of times, I think I've mentioned this, students kind of flip-flop. They mix up intermediate value theorem and mean value theorem. Intermediate value theorem is to prove the existence of a function value on the interval. The only condition is that the function has to be continuous on the closed interval, and the function values at the endpoints can't be equal to each other. Mean value theorem is saying the function has to be continuous on the closed interval so that you can consider like the average rate of change, the slope of the secant line on that interval. And then it has to be differentiable on the open interval because we're saying that somewhere on the open interval, the derivative is going to take on the same value as the slope of the secant line, as the average rate of change. Are we following this? Cool. So there exists a number C on the open interval such that f prime of C is equal to average rate of change. So f prime of C, right, would be slope of this tangent line at x equals to C, and f of b minus f of a over b minus a would be the slope of this secant line on the interval from a to b. And then I've given you some visuals of like how this happens, how this could happen, what it could look like. Okay, so MVT guarantees at least one value of C such that f prime of C is equal to the average rate of change. The slope of the tangent line is equal to the slope of the secant line. Rolle's theorem is a special case of MVT in which f of a equals to f of b. In this case, the conclusion is that f prime of C would be equal to 0. But you could think about it, if you're like, oh, conditions for mean value theorem apply. When you go to calculate the average rate of change on the interval, if f of a equals to f of b, you would just get 0, right? So really, mean value, like College Board only references mean value theorem, but if you were to recognize you're in a Rolle's theorem situation where you could use Rolle's theorem as your justification, that's allowed to use.
Is it easy?
What? No.
Be faster.
No. And then just, this is an alternate. I don't know if I would necessarily say that useful to you at this point. I was trying to remember like where this would come up again. Hopefully you can see, if you were to multiply by b minus a on each side of this equation, that has to be true for mean value theorem, and then add f of a to each side, like it just manipulates this statement. I feel like this comes up, this is kind of like from Euler's method, but anytime you're like doing function like a linear approximation type method for approximating a function value, this kind of form of the mean value theorem could kind of come up. But again, this is not something that I would really get too hung up on. Stay tuned. Okay, so let's do one of these together. And again, this is kind of a more textbook type problem, and the wording's not super clear. So we're going to verify the MVT with f of x equals square root of x for a equals to 1 and b equals to 9. So we're going to answer two questions. So does MVT apply on this interval? And we're going to justify. Okay. And then we're going to find, if it does, we're going to find the value C, where f prime of C would be equal to f of B minus f of A over B minus A. Okay. So first of all, square root of x, this is referencing the interval from 1 to 9. Is the square root of x continuous on the closed interval from 1 to 9? Yeah. Is it differentiable? Yeah. Okay. So we can say f is continuous on the interval from 1 to 9 and differentiable. So basically, yes, MVT does apply. And differentiable on the open interval from 1 to 9. Therefore, by MVT, there exists a value C such that f prime of C is equal to f of 9, minus f of 1 over 9 minus 1, which we can calculate what that is, because f of 9 will end up being 3 minus f of 1 is 1 over 8. So is that 2/8 or 1/4? So we can conclude that because f is continuous on the closed interval, differentiable on the interval, there's going to be some value on the interval. Oh, and I should say some value C on the open interval from 1 to 9, such that f prime of C would be equal to 1/4. And then once we've proved that it would exist, that value has to exist, then we can find it. So we need f prime. Am I going too fast? Are we doing okay?
Yeah.
Okay. So finding f prime, that would be 1 over 2 root x, okay? And then we want to find the value of x where f prime would be equal to 1/4, so we can just think about setting our derivative equal to 1/4. We end up with root x would be equal to positive 2, meaning x will be equal to positive 4. So we could say C will be equal to 4 such that f prime of 4 is equal to 1/4, or if you want to write this out, like drive it home. Yeah. So now you guys are going to do the next one. I'm going to put you into groups.
Could you go back?
Yes, I can. I'm just going to cut. My right hand's longer. Or maybe do that one later. Your right arm's longer than hers.
You think so? I don't think so.
so.
I think mine's longer.
Test it out.
That's my left.
That's your left. Yours is
Yeah.
right.
My left is
They're not necessarily the same.
not the same.
They're not.
Okay, get up. Wait, how do you
I
do
feel
it?
like you have to go shoulder. It would be tricky.
Shoulder.
You have to go like shoulder,
Shoulder.
or like go like next to each other.
Because I'm so tall, it's gonna be like really different.
Okay, let's
Get
see.
up. Wait.
No, like
Wait.
line up like Elisa comes like behind you. Okay, so try. Yeah. No. Turn. Which is your right? That's right. Yeah, so you put your arm out.
Okay.
No, fingertip. Fingertip. Okay, nails don't count.
Okay.
Lisa's are significantly
I
longer.
don't like this game.
Okay, this half of the room, you guys are at that board. Other half, you're over at that board. Okay, so you're doing the next one. Now, 2 questions again, you're answering. Let's break it down to be, does MVT apply? Like justify? Did you say I bet it applies?
Yeah.
Well, sometimes they are tricky, and like there's free responses where it's like you have to state why MVT would not apply, like why the derivative value would not, you couldn't guarantee it. And then you're going to find C.
Oh, can we do it on the board?
Do it on the board. So you're this board over here, because you're this half of the room. So you guys go through it together.
Who's having the board privilege? I have the board privilege.
I don't know. I mean, I definitely know. Whatever.
Oh, so tall.
Continuous.
Wait, I got it.
Alright, wait, so wait, can I try? Wait, can I try?
That was an accident.
Okay.
You
It's like under homework. Just as important as everything. Right, wait, we have to define. Oh, I thought it was like
No, that's bad.
yeah, that would be pretty bad.
That's-
Wait, what was the justification? Oh, whoops, that was supposed to click on Schoology.
I did have it in my, for the longest time. I had YouTube in my like bar at the bottom of my phone. That's fine.
You're slanting.
Wait, did we do outline?
Us too.
No,
That's
I'm
nice.
Yeah.
moving to his group.
Does it do outlining or what?
Okay.
How's it going?
No. Take that.
Oh, that's too. You're watching people reconcile food.
Is that?
Are things like black? Oh. It's really sad to say. You're like 5 inches taller than everyone else. He thinks he's really black. So the video we seen had like reverse. Okay, you're not that.
Hey, it doesn't sound like we're talking mean value theorem over here.
Yeah.
It looks like it. It's gonna be.
Wait, differential volt? What is happening
Content.
So you're using your pre-calc knowledge a bit to answer like the first 2 conditions, right?
Therefore.
We do this, right?
Oh, wait.
I think. Wait, is that a part of this?
Wait, yeah, I know what it is. Like you find the derivative.
Well,
Two,
okay, so this is like.
So
right.
wait, no, you have it there.
You can have your.
Wait, what's like the definition?
Yeah.
Just love it that.
Guys, pull up the calc. Short calculator.
Why do you need the calc? You don't need the calc.
You don't need a calculator for calculator?
No, you
Well,
don't.
you calculus,
I can do
like,
it now.
for calculate this, like,
Wait,
equation, it's pretty complicated.
You have the function.
Yeah, you can just.
Yeah, but like, I wanna do mental math.
Bro, like.
Okay, do you,
Okay, sure. Okay, let's see.
Find the tangent line of this.
Okay, let's
Zero.
Okay, let's see. What's that for?
0.
Oh yeah, you're right. Okay,
Minus
0
2,
minus, and what's that?
minus
Negative
3.
2. Okay.
Over, no, negative 1.
Negative 3? Okay, so 0 plus 3. There you go. Okay, so what's 1 plus 3? Okay, there you go. So you got 1.
He's rage baiting you all.
There you go, I solved it, guys. Okay.
That was equal.
Throw it in the garbage.
Wait, so what do we do now?
Rubbish bin.
The second step?
Rubbish can?
Okay, so I actually don't.
You want to differentiate?
Oh, well, okay.
Sure, that's a good idea.
Oh, okay, no, I was too red.
What? Aren't you supposed to find this one first? You're supposed to find. Oh.
Shoot that.
Okay.
Isn't it, wouldn't it be,
And plus. Minus.
wouldn't it be 4
So x equals to square root of x.
over, because you need the parentheses around the x minus 1.
I hate
Oh,
I
yeah.
Why would anyone?
This door shut your head about after the after the work. Alright.
Oh, yeah, they are. They are.
Wait.
Okay, sorry.
Maybe that
Wait,
would
hold on. Are you sure? Just be a 4, yeah.
Yes.
Alright. I mean, I think that's done. We're done.
Okay, make sure you take a picture of your work.
Oh yeah. Wait, hold on. Can I do this?
How do we put the line?
Okay, so we have to do the second problem, right? But what if you're always running out of space? That's what happens.
Okay.
Do we need to do the next problem?
Yeah, so next one. So after you guys finish this one, give the next one a peek. And I will say there's some extra information in the next one. And remember, you're in mean value theorem land.
Fine, I'll do another one.
You know you're not going to have
I'm sure you're
space.
capable of that. Not for any particular reason.
Oh, so it's 11-1. It's already drawn.
Oh yeah, that's right. It's okay. It's okay. You can still draw it on the board. It's okay.
What?
No.
Why do you do these things?
No, you have to take it off.
I think
Oh, sorry.
it's
Okay, anyway, at 55 miles per hour,
You're ganging up on me.
Have some picture time.
Would both of those be C?
Wait, so.
Oh no.
Okay,
Not
let's,
negative
okay, you
five.
know what, I actually don't know how to approach
No,
this.
negative 5.
Oh, wait.
Okay, so what do we have? Wait, so we have
So why
time
did
t
you
equals
wait, no, 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 no.
Just put, actually put negative 5, we should cross it out. Yeah.
Okay, I
So
understand your instruction. We should put negative 5.
D
and then we should
dx
cross out negative
over dt initial, right? That's 55
What are you doing?
miles per hour, right? And then we have
To cross out negative 5.
dx over dt
You
5.
can cross out negative 5.
50?
Have
we done this before?
Yeah.
It's you're in mean value theorem land and there's extra information. So let me ask you this. With knowing that the speed, like the first, like if I'm driving to school, there's a police officer that blocks me and is like, what? This person's driving 55 miles per hour. And then I get off at Cage and I'll drive 50 miles per hour or whatever. Would they be able to prove that I went over the speed limit at 55 miles per hour? Just knowing those two speeds?
No, I don't get why we're doing
Now, by IVT, that would prove that I drove between 50 and 55 miles per hour, but like that wouldn't prove that I went over the speed limit. But
But yeah.
don't you know how long it took for the truck to drive 5 miles? Like if I told you the distance I drove to school and how long it took me to get here, couldn't you figure out what my average speed was
What is that?
in driving? Or my average rate of change? So after you guys finish that one, you're moving on to the truck one.
We make it look like a
Wait, do
eating
cops
math
actually do
problem.
that? Are they like, oh, it took you 5 miles, and like in 5? And they?
Like for technically, right? By the mean value theorem, your
Couldn't
average
have
rate
gone
of
this way.
change.
No, but they can't because like, oh, well, I guess it's like a highway.
They like
There's
take a
lights.
shortcut to go to another spot, and then they're like,
Okay.
it took you this long to get
That's right.
here.
Is there a light in between
Is
the
it,
5
did you use the
miles?
line?
It took us this long to get here and we're already seeing all of it.
Yep. It's like the,
Wait,
the Buddhist.
And who held us up?
Five,
Oh, no, I get it. I was trying to get it.
You wrote as Friday we'll see.
75,
Such you didn't
okay.
even abbreviate such.
Wait, so IBT, you need the continuous, this is continuous, right? It is differentiable in
Speed
each
is
one.
passable.
Yeah, exactly. Wait,
Okay, that's
hold on.
probably.
We have to write it out.
Finding it instantaneous rate.
Okay, so
Two
firstly,
stationary patrol cars each other are 5 miles apart on a highway. As
okay,
the truck passes the first patrol car,
Speed.
its speed is clocked
Wait, we're
at
talking
55 miles per hour. For 15
so yeah,
minutes
that's the
later,
time in
oh,
minutes.
4
Because we have minutes, that's per hour.
4 minutes
Use-
later,
When the truck passes the second
There's no 50.
It's speed
I
of
guess-
50 miles per hour. Speed of
Oh, I
Prove that the truck was exceeding the speed limit of 55 miles per hour at some time during the 4 minutes. Oh, we're doing mean value.
We're in mean value theorem land.
So
Wait,
what else?
how do you know that?
One?
Because we need to say that it's at some time.
And differential.
Okay,
yeah.
so the interval,
Well, not speed,
is-
actually, position.
5, wait,
Um,
the interval is
0 and 5.
Oh, right, it goes 5 miles per minute.
Yeah, but, yeah, exactly, yeah.
I like
We need to like,
that you
we need
So if it, could you figure out in maybe like in miles per hour what the truck driver's average speed was
by,
Oh,
for driving 5 miles in 4 minutes?
so,
I guess we call it, what?
oh, we do 5 over 4
No.
miles,
That's
1/4
60.
miles
How
per
many
minute.
Past equals to
hours?
what?
Oh, per minute, yeah.
5.
Okay, so now we have to find the slope, 75,
How
right?
much of an hour?
5 miles in 4 minutes. Is that over 55 miles per hour?
Okay, 5 miles over
Like,
4
oh wait,
minutes
here,
is
here,
equal
here,
to
here.
x
0
miles.
minus
Oh,
Five.
5.
x of 4 minus x
Okay,
of
I'm gonna do math.
over
5
4
over
minus
4
0
is equal
equals
to
to
x.
75.
X times c. 5 times
75 miles. I got it.
No, because that's
See what I meant to-
so this is
You know what?
150
You're gonna make it look like I did all
and
the
then
work.
150
using green.
minus 0.
Different shade of green.
Therefore, this is equal to 75. Okay, cool. And therefore, I think this is equal.
Okay, tell me
Therefore,
about
this truck is illegal.
average,
Spend the dollar.
It
average-
exceeded speed limit illegally.
average rate of
We need to put him to jail now, the whole truck. Not just the truck.
Position, yeah. So you assume a position.
And he,
We'll see this.
Yeah.
Do we do the next problem or no?
There isn't a next problem. We are going to move on to 3.3 in just a second here. So if you need to go to the restroom, Dennis, it's probably a good time.
I thought I already finished the problem.
I think you're a little faster.
Well, no, just literally look at what you need for MBT from the previous problem and see if you can apply it here, and then you got it. Okay.
There's not really like a strict wait, like this is more of a textbook problem. Like it's like, is there proof that there is a truck? So by mean value theorem, like yes, there would have to be a time between the 0 and 4 minutes of the truck driving that the truck would have to be driving 75 miles per hour, which is definitely more than the speed limit of 55 miles per hour.
Okay. So we say that.
Here.
Oh,
is
is it?
Because if you're thinking about position, like tracking the truck's position, like position would be continuous,
But T is an hour.
or assuming position would be. So assuming that, yeah, so that you could say like, yes, this rate is greater than the speed limit.